Do you want to successfully complete the D429 objective assessment exam? Then you are in the right place. Our website provides a list of questions and answers for your success in the D429 OA exam for free. We understand that acing your OA exam can be quite challenging. That's why we provide completely free exam guides and practice questions for you. In this video, we will cover questions from natural language processing, AI ethics, intelligent agents, computer vision, and machine learning. So, let's get started. 1. A healthcare startup wants to diagnose rare diseases from medical images, but has limited labeled data. Which learning approach would best address their challenge while maintaining diagnostic accuracy? A. Supervised learning only. B. Semi-supervised learning approach. C. Unsupervised clustering exclusively. D. Rule-based expert system. Can you guess the answer? Correct answer. B. Semi-supervised learning approach. Explanation. Option B is correct because semi-supervised learning combines small labeled datasets with large unlabeled data, perfect for scenarios where labeling is expensive but unlabeled data is abundant. Option A is incorrect because supervised learning alone requires extensive labeled data, which the startup lacks, making it impractical for rare disease diagnosis. Option C is incorrect because unsupervised clustering cannot provide specific disease diagnoses without any labeled examples to guide the learning process effectively. Option D is incorrect because rule-based systems require explicit programming of all diagnostic rules which may not capture complex patterns in medical images. Alright, let's break down the core concept behind this question about learning approaches in AI. When we have limited labeled data, but abundant unlabeled data, like in medical imaging for rare diseases, we need a smart strategy. Semi-supervised learning is the perfect solution here, because it leverages both types of data. Think of it like having a few expert annotated examples to guide the learning process while using the massive amount of unlabeled images to understand patterns and structures. This approach bridges the gap between fully supervised learning, which needs lots of labels, and unsupervised learning, which can't provide specific diagnoses. It's particularly powerful in healthcare where expert labeling is expensive and time-consuming. 2. Your company's AI chatbot is experiencing the vanishing gradient problem during training. Which neural network architecture would most effectively solve this issue while maintaining sequence processing capabilities? A. Simple RNN network. B. LSTM network architecture. C. Convolutional neural network. D. Simple reflex agent. Do you know the answer? Correct answer, B. LSTM network architecture. Explanation. Option B is correct because LSTM networks use memory cells and gates specifically designed to handle vanishing gradient problems while processing sequential data like conversations. Option A is incorrect because simple RNNs are particularly susceptible to vanishing gradient problems, which is exactly the issue the company needs to solve. Option C is incorrect because CNNs are optimized for grid-like data such as images, not sequential conversation data that chatbots process. Option D is incorrect because simple reflex agents only respond to current inputs without memory, making them unsuitable for conversational context. To really understand why LSTM is the correct choice for fixing vanishing gradients, let's explore what makes neural networks struggle with sequences. When processing conversations in a chatbot, information needs to flow through many layers over time. Regular RNNs suffer because gradients become exponentially smaller as they travel backward through time, like a telephone game where the message gets weaker. LSTMs solve this with special gates and memory cells that act like highways for gradients. These gates carefully control what information to remember, forget, and output. maintaining strong gradient flow even through long sequences. This architecture specifically targets the vanishing gradient problem, while keeping the sequential processing capabilities essential for understanding conversation context. 3. A robotics company needs their warehouse robot to navigate through a partially observable environment with multiple other robots. Which agent characteristic combination would be most appropriate for this scenario? A. Simple reflex multi-agent. B. Learning agent multi-agent. C. Software agent single. D. Model-based reflex single. Can you guess the answer? Correct answer, B. Learning agent multi-agent. Explanation. Option B is correct because learning agents can adapt to partially observable environments through experience, while multi-agent capability handles coordination with other robots effectively. Option A is incorrect because simple reflex agents cannot handle partially observable environments as they only react to current percepts without memory. Option C is incorrect because software agents are programs without physical interaction capabilities needed for warehouse navigation, and a single agent ignores other robots. Option D is incorrect because a single agent configuration doesn't account for the multiple robots that must coordinate in the warehouse environment. This is a critical concept for multi-robot systems, so let's dig into why learning agents in multi-agent settings work best. In a warehouse with multiple robots and partial observability, each robot can only see its immediate surroundings, not the entire warehouse. Simple reflex agents would constantly collide because they only react to current inputs without memory or planning. But learning agents adapt through experience, building internal models of the environment and learning to predict other robots' behaviors. The multi-agent aspect is crucial because robots must coordinate movements, share space, and avoid conflicts. They learn optimal paths not just based on static obstacles, but by understanding patterns of how other robots move, creating an efficient collaborative system. 4. Your team discovered that your facial recognition system performs poorly on certain demographic groups. Which ethical AI principle is primarily violated, and what technique would best address this issue? A. Transparency and federated learning. B. Fairness and dataset augmentation. C. Accountability and differential privacy. D. Privacy and key anonymity. Do you know the answer? Correct answer, B. Fairness and dataset augmentation. Explanation. Option B is correct because the bias violates fairness principles, and dataset augmentation can increase diversity in training data to improve performance across all demographics. Option A is incorrect because transparency relates to explainability of decisions, and federated learning addresses privacy concerns rather than demographic bias issues. Option C is incorrect because accountability involves governance frameworks, while differential privacy protects individual data rather than addressing performance disparities. Option D is incorrect because privacy and k-anonymity protect individual identification but do not address the fundamental bias in model performance. Let's explore the critical relationship between fairness and dataset augmentation in AI ethics. When facial recognition performs poorly on certain groups, it violates the fairness principle, creating discriminatory outcomes. This isn't about privacy or transparency, but about equal treatment. The bias emerges from training data that lacks diversity, causing the system to learn features predominantly from overrepresented groups. Dataset augmentation specifically addresses this by artificially expanding the training data to include more diverse examples. This might involve adding images with different lighting conditions, angles, and importantly, ensuring representation across all demographic groups. By balancing the dataset, we teach the AI to recognize facial features universally, not just for specific populations. 5. An e-commerce platform experiences sudden traffic spikes during flash sales that overwhelm their static infrastructure. Which AI system characteristic would best handle these unpredictable demand patterns automatically? A. Episodic task environment. B. Rapid elasticity capability. C. Static environment processing. D. Discrete state representation. Can you guess the answer? Correct answer, B. Rapid elasticity capability. Explanation. Option B is correct because rapid elasticity allows systems to automatically scale resources up or down based on demand, perfect for handling unpredictable traffic spikes. Option A is incorrect because episodic environments involve independent episodes, but e-commerce traffic requires continuous operation with varying load patterns. Option C is incorrect because static environment processing assumes unchanging conditions, which contradicts the dynamic nature of flash sale traffic. Option D is incorrect because discrete state representation relates to how states are modelled, not the system's ability to handle varying loads. Understanding rapid elasticity is crucial for modern AI systems handling variable loads. When an e-commerce platform faces flash sales, traffic can spike from hundreds to millions of requests within minutes. Static infrastructure would crash under this sudden load, while oversized permanent infrastructure wastes resources during normal periods. Rapid elasticity is the capability to automatically scale computing resources up or down based on demand. Think of it like an accordion that expands when you need more capacity and contracts when demand drops. This isn't about the type of environment or how states are represented, but about the system's ability to dynamically adjust its resources. The AI system monitors metrics and triggers scaling actions automatically, ensuring consistent performance regardless of traffic variations. 6. A financial institution wants to detect fraudulent transactions in real time. Which combination of data quality dimensions would be most critical for building an effective fraud detection system? A. Completeness accuracy. Timeliness. B. Uniformity, consistency relevance. C. Veracity, completeness uniformity. D. Consistency relevance veracity. Do you know the answer? Correct answer, A. Completeness accuracy timeliness. Explanation. Option A is correct, because fraud detection requires complete transaction data, accurate labeling of fraud cases, and timely processing for real-time detection capabilities. Option B is incorrect because uniformity is less critical than timeliness for real-time fraud detection, where immediate response prevents financial losses. Option C is incorrect because uniformity isn't essential for fraud detection, and this combination lacks the critical timeliness component for real-time processing. Option D is incorrect because while consistency and relevance matter, missing timeliness and accuracy makes real-time fraud detection ineffective. For fraud detection systems, 3 data quality dimensions stand out as absolutely critical. Completeness ensures we have all transaction details without gaps that fraudsters could exploit. Think of it like a puzzle where missing pieces could hide fraudulent patterns. Accuracy means our historical fraud labels are correct, as wrong labels teach the AI to recognize the wrong patterns. Timeliness is perhaps most crucial because fraud must be caught in real time before money is lost. While consistency and relevance matter, they're secondary to having complete, accurate, and timely data. Without timeliness, even perfect fraud detection is useless if it happens after funds are transferred. These 3 dimensions work together to create an effective defense against financial fraud. 7. Your autonomous vehicle must decide between hitting 1 pedestrian or 5 pedestrians in an unavoidable accident scenario. This ethical dilemma best illustrates which AI development challenge. A. Gorilla problem concern. B. King Midas problem. C. Sybil attack vulnerability. D. Superintelligence alignment issue. Can you guess the answer? Correct answer. B. King Midas problem. Explanation. Option B is correct because the King Midas problem involves optimization without considering broader consequences, like reducing casualties without addressing ethical implications. Option A is incorrect because the gorilla problem concerns creating uncontrollable AI, not ethical decision-making in predetermined scenarios with limited options. Option C is incorrect because Sybil attacks involve fake identities, manipulating systems, unrelated to ethical decision-making in accident scenarios. Option D is incorrect because superintelligence alignment concerns future AI surpassing human intelligence, not current autonomous vehicle ethical dilemmas. The King Midas problem perfectly captures this autonomous vehicle dilemma about unintended consequences. Remember King Midas, who wished everything he touched would turn to gold, only to realize he couldn't eat or embrace loved ones. Similarly, if we program a vehicle to simply minimize casualties, it optimizes that goal without considering broader ethical implications. The vehicle might correctly calculate that hitting one person causes less harm than 5, but this pure optimization ignores questions like the moral weight of actively choosing to harm someone versus allowing harm to occur. It's not about control, fake identities, or future superintelligence, but about how narrow optimization can lead to ethically problematic outcomes when we don't consider all consequences. 8. A manufacturing plant wants to implement predictive maintenance using sensor data from equipment. Which data pre-processing technique would be least useful for preparing this time series sensor data? A. One-hot encoding transformation. B. Z-score normalization method. C. Outlier detection removal. D. Missing value imputation. Do you know the answer? Correct answer. A. One-hot encoding transformation. Explanation. Option A is correct because one-hot encoding is for categorical data, while sensor readings are continuous numerical values that don't require categorical transformation. Option B is incorrect because Z-score normalization is highly useful for standardizing sensor readings from different equipment with varying measurement scales. Option C is incorrect because outlier detection is crucial for identifying potential equipment malfunctions or sensor errors in the data. Option D is incorrect because imputation handles missing sensor readings due to temporary failures, maintaining data continuity for analysis. Let's understand why one-hot encoding is the wrong tool for sensor data pre-processing. Sensor data from manufacturing equipment produces continuous numerical values like temperature readings, pressure measurements, and vibration frequencies. One-hot encoding is designed for categorical data, where you need to represent distinct categories like colors or product types as binary vectors. Applying one-hot encoding to continuous sensor values would destroy their numerical relationships and create massive, sparse matrices. In contrast, normalization scales these continuous values to comparable ranges. Outlier detection identifies equipment malfunctions, and imputation fills gaps from temporary sensor failures. These techniques preserve the numerical nature of sensor data while preparing it for analysis. 9. A news aggregation platform needs to process articles from multiple sources while avoiding copyright infringement. Which NLP approach would best extract key information without reproducing protected content? A. Bag of words frequency analysis. B. Semantic network extraction. C. Word embedding generation. D. Direct corpus compilation. Can you guess the answer? Correct answer. A. Bag of words frequency analysis. Explanation. Option A is correct because bag of words analyzes word frequency patterns to identify topics without reproducing original text structure or violating copyright protections. Option B is incorrect because semantic networks might capture and represent relationships in ways that could reproduce protected expression patterns. Option C is incorrect because word embeddings capture semantic meanings that could indirectly reproduce protected creative expressions from source materials. Option D is incorrect because direct corpus compilation involves collecting and storing original texts, directly raising copyright infringement concerns. To understand why Bag of Words helps with copyright concerns, let's examine how it processes text. When dealing with copyrighted articles, reproducing content structure or expression violates copyright. Bag of Words strips away all structural information, treating text as an unordered collection of word frequencies. Imagine taking a beautiful poem and just counting how many times each word appears, losing all artistic arrangement. This approach extracts topical information through word statistics without preserving the creative expression that copyright protects. Unlike semantic networks that capture relationships, embeddings that encode meaning, or corpus compilation that stores original text, Bag of Words transforms content into abstract frequency data that can't reconstruct the original protected expression. 10. Your team needs to select a reasoning method for a medical diagnosis system where explaining decisions to doctors is mandatory. Which knowledge representation method best supports this requirement? A. Description logic system. B. Neural network approach. C. Probabilistic context-free grammar. D. Transformer architecture model. Do you know the answer? Correct answer. A. Description logic system. Explanation. Option A is correct because description logics provide formal, structured definitions with traceable reasoning paths, enabling clear explanations of diagnostic decisions to doctors. Option B is incorrect because neural networks are often black boxes that cannot easily explain their decision-making process to medical professionals. Option C is incorrect because probabilistic context-free grammars are designed for language structure analysis, not medical reasoning with explainable outputs. Option D is incorrect because transformer architectures, while powerful, lack the inherent explainability needed for medical diagnosis justification. Description logic stands out for medical diagnosis systems because of its unique explainability features. In healthcare, doctors must understand and verify AI recommendations before making critical decisions. Description logics provide formal, structured definitions using concepts and relationships that create clear reasoning chains. Imagine a diagnosis system that can show exactly why it concluded a patient has pneumonia, tracing through symptoms, test results, and medical rules step by step. Neural networks, despite their accuracy, operate as black boxes where decisions emerge from millions of weighted connections impossible to interpret. Transformers and probabilistic grammars, while powerful for other tasks, lack the formal reasoning structure that makes medical decisions transparent and trustworthy to healthcare professionals. 11. A smart city project needs to coordinate traffic lights, emergency vehicles, and public transportation in real time. Which agent environment characteristics best describe this system's requirements? A. Fully observable, deterministic episodic. B. Partially observable, dynamic multi-agent. C. Unobservable, static discrete. D. Fully observable, sequential single. Can you guess the answer? Correct answer. B. Partially observable, dynamic multi-agent. Explanation. Option B is correct because traffic systems have limited visibility, change continuously, and involve multiple autonomous agents requiring coordination for optimal citywide performance. Option A is incorrect because city traffic is neither fully observable nor deterministic, and episodes are not independent in traffic flow. Option C is incorrect because traffic systems require some observability for coordination and are highly dynamic, not static environments. Option D is incorrect because a single agent configuration cannot handle the coordination between multiple traffic lights and vehicle systems. Smart city traffic coordination showcases the complexity of multi-agent dynamic environments. The system is partially observable because no single sensor can see all vehicles, pedestrians, and conditions across the entire city. It's dynamic because traffic patterns change constantly throughout the day, with rush hours, accidents, and events creating unpredictable variations. The multi-agent aspect is crucial, with traffic lights, emergency vehicles, and public transport all acting as independent agents that must coordinate. Each traffic light makes decisions based on local information, while considering system-wide optimization. This isn't episodic because traffic flow is continuous, and it's definitely not static or fully observable. Understanding these characteristics helps design AI systems that handle real-world complexity. 12. Your company's sentiment analysis model consistently misclassifies sarcastic customer reviews as positive feedback. Which NLP enhancement would most effectively address this limitation? A. Increase tokenization granularity. B. Add bidirectional processing. C. Implement one-hot encoding. D. Use bag of words model. Do you know the answer? Correct answer, B. Add bidirectional processing. Explanation. Option B is correct because bidirectional processing analyzes context from both directions, capturing subtle patterns and contradictions that indicate sarcasm in text. Option A is incorrect because tokenization granularity affects word segmentation, but doesn't help understand the contextual nuance of sarcasm. Option C is incorrect because one-hot encoding is a basic representation that cannot capture the complex semantic relationships in sarcastic text. Option D is incorrect because bag of words ignores word order and context, making it impossible to detect sarcasm's subtle patterns. Sarcasm detection reveals why bidirectional processing is essential for understanding context. Sarcasm works by saying one thing while meaning the opposite, requiring the model to understand the full context in both directions. Consider the phrase, "Oh great, another delay." Reading forward suggests positivity with great, but the backward context of another delay reveals the negative sentiment. Bidirectional RNNs or transformers process text from both left to right and right to left simultaneously, capturing these contradictions. Simple tokenization just breaks text into pieces. One-hot encoding loses sequence information entirely, and bag of words completely ignores word order. Only bidirectional processing can detect the subtle interplay between words that create sarcastic meaning. 13. A research team studying climate change needs to process satellite imagery showing deforestation patterns over decades. Which computer vision approach would best track these gradual environmental changes? A. Active sensing reconstruction. B. Passive sensing recognition. C. Feature extraction comparison. D. Object model matching. Can you guess the answer? Correct answer, C. Feature extraction comparison. Explanation. Option C is correct because feature extraction identifies key visual attributes across time periods, enabling comparison of forest coverage changes in satellite imagery. Option A is incorrect because active sensing requires emitting signals, which satellites don't do for Earth observation imaging tasks. Option B is incorrect because recognition distinguishes between objects, but doesn't track how the same area changes over time. Option D is incorrect because object models assume consistent objects, but deforestation involves gradual transformation rather than discrete object matching. Tracking deforestation through satellite imagery demonstrates the power of feature extraction comparison. When monitoring environmental changes over decades, we need to identify and compare specific visual characteristics across time periods. Feature extraction identifies key attributes like forest density, canopy coverage, and bare soil patterns in each image. By comparing these extracted features between images from different years, we can quantify exactly how much forest has been lost and where. Active sensing isn't applicable since satellites use passive cameras. Recognition just identifies objects without tracking changes, and object models assume static objects rather than gradual transformation. Feature extraction comparison provides the precise measurement of environmental change needed for climate research. 14. Your startup is developing a personal assistant that must remember user preferences across conversations. Which agent component specifically enables this capability while suggesting new features to explore? A. Performance element only. B. Critic component exclusively. C. Problem generator element. D. Complete learning agent. Do you know the answer? Correct answer, D. Complete learning agent. Explanation. Option D is correct because a complete learning agent integrates performance, evaluation, and exploration, allowing it to remember preferences and suggest new features. Option A is incorrect because the performance element only executes actions based on current knowledge without learning or suggesting new features. Option B is incorrect because the critic component evaluates actions but does not remember preferences or suggest new features. Option C is incorrect because the problem generator suggests explorations but does not remember preferences or execute actions. A complete learning agent architecture is essential for personal assistants that evolve with users. The performance element executes current tasks like setting reminders and answering questions based on learned preferences. The critic component evaluates whether responses satisfied the user, learning from feedback to improve future interactions. Most importantly, the problem generator suggests exploring new features the user might enjoy but hasn't tried yet. This complete system creates a dynamic assistant that not only remembers your coffee order, but also suggests trying a new podcast based on your interests. Individual components alone can't achieve this. Without all three working together, the assistant would either blindly execute without learning, evaluate without acting, or explore without purpose. 15. A social media platform discovers their content moderation. AI is being manipulated by coordinated fake accounts. Which type of attack is occurring, and what principle does it violate? A. Sybil attack identity uncertainty. B. King Midas optimization problem. C. Existence uncertainty manipulation. D. Gorilla problem uncontrollability. Can you guess the answer? Correct answer. A. Sybil attack identity uncertainty. Explanation. Option A is correct because Sybil attacks use multiple fake identities to manipulate systems, exploiting identity uncertainty where true user identities are unknown. Option B is incorrect because King Midas problems involve unforeseen and undesirable consequences from optimization, not coordinated manipulation through fake account networks. Option C is incorrect because existence uncertainty questions whether entities truly exist, while Sybil attacks involve definitely existing fake accounts. Option D is incorrect because the gorilla problem concerns AI achieving goals in unintended ways, potentially becoming uncontrollable, not external actors manipulating AI through fake accounts. Sybil attacks represent a fundamental security threat, exploiting identity uncertainty in AI systems. Named after the famous case of multiple personality disorder, these attacks involve creating numerous fake identities to manipulate system behavior. In the social media content moderation, attackers create armies of fake accounts that coordinate to overwhelm the AI's decision-making. They exploit identity uncertainty because the system cannot verify if accounts represent real, unique individuals or are controlled by a single malicious actor. This isn't about optimization problems or AI control, but about external manipulation through deception. The fake accounts can mass report legitimate content or promote harmful content, gaming the system's algorithms that assume each account represents an independent user opinion. 16. An insurance company wants to predict claim likelihood using customer data including age, location, and driving history. Which machine learning task type and algorithm combination is most appropriate? A. Classification with k-means. B. Regression with random forest. C. Classification with logistic regression. D. Clustering with decision tree. Do you know the answer? Correct answer, C. Classification with logistic regression. Explanation. Option C is correct because predicting claim likelihood is a binary classification problem, and logistic regression effectively handles multiple input features for probability prediction. Option A is incorrect because k-means is an unsupervised clustering algorithm that cannot predict specific outcomes like claim likelihood. Option B is incorrect because while regression predicts continuous values, claim likelihood is typically a categorical yes or no classification problem. Option D is incorrect because clustering groups similar data points without predicting specific outcomes, and decision trees are classification algorithms, not clustering algorithms. Insurance claim prediction perfectly illustrates the distinction between classification and regression in machine learning. When predicting claim likelihood, we're answering a yes or no question. Will this customer file a claim? This binary outcome makes it a classification problem. Logistic regression, despite having regression in its name, is actually a classification algorithm that outputs probabilities between 0 and 1. It processes multiple features like age, location, and driving history through a sigmoid function to produce claim probability. K means clusters data without predicting outcomes. Standard regression predicts continuous values like claim amounts, and clustering groups similar customers without making predictions. The combination of binary outcome and probability output makes logistic regression ideal for claim likelihood prediction. 17. Your team needs to process customer support emails that contain both structured metadata and unstructured message content. Which data type classification best describes this email data? A. Fully structured data. B. Completely unstructured data. C. Semi-structured data type. D. Quasi-structured data format. Can you guess the answer? Correct answer, D. Quasi-structured data format. Explanation. Option D is correct because quasi-structured data like emails has structured elements such as headers and timestamps alongside unstructured message body content. Option A is incorrect because fully structured data would require all content, including message bodies, to follow a rigid schema. Option B is incorrect because emails contain structured metadata like sender, date, and subject that follow consistent formats. Option C is incorrect because semi-structured data has some organizational properties throughout, while emails have distinct structured and unstructured portions. Email data structure reveals the important distinction between semi-structured and quasi-structured data types. Quasi-structured data has distinct regions with different organizational levels. In emails, headers follow strict formatting with fields like from, to, date, and subject in predictable structures. However, the message body is completely unstructured, containing free-form text without any schema. This dual nature defines quasi-structured data. Semi-structured data like JSON has organizational properties throughout, while fully structured data requires everything to follow rigid schemas. Completely unstructured data lacks any formal organization. Understanding this classification helps choose appropriate processing techniques, using structured methods for headers while applying NLP to message bodies. 18. A video game company wants their NPC enemies to learn player strategies through gameplay. Which reinforcement learning characteristic would be most challenging in this video game environment? A. Sparse reward signals. B. Continuous action space. C. Fully observable state. D. Deterministic outcomes. Do you know the answer? Correct answer, A. Sparse reward signals. Explanation. Option A is correct because games often provide rewards only at completion or checkpoints, making it difficult for agents to learn from infrequent feedback. Option B is incorrect because most games use discrete actions like move, attack, or defend rather than continuous action spaces. Option C is incorrect because fully observable states would actually help learning, not present a challenge for the NPC agents. Option D is incorrect because deterministic outcomes make learning easier by providing consistent results for the same actions. Sparse rewards represent one of reinforcement learning's biggest challenges in gaming environments. In many games, rewards only come at major milestones like completing a level or defeating a boss, with long periods of no feedback in between. Imagine learning to play chess where you only get feedback when the game ends, not for individual moves. This sparsity makes it extremely difficult for AI agents to understand which specific actions contributed to success or failure. The agent might make hundreds of decisions before receiving any reward signal, creating a credit assignment problem, unlike continuous action spaces or deterministic outcomes which actually simplify learning. Sparse rewards force agents to explore extensively and maintain long-term memory of action sequences. 19. Your organization must comply with CCPA while training a machine learning model on customer data. Which privacy-preserving technique would best maintain model performance while ensuring compliance? A. Complete data deletion. B. Differential privacy implementation. C. Rule-based filtering only. D. Manual anonymization process. Can you guess the answer? Correct answer, B. Differential privacy implementation. Explanation. Option B is correct because differential privacy adds controlled noise to protect individual privacy while maintaining statistical properties needed for effective model training. Option A is incorrect because complete deletion would eliminate the training data entirely, making model development impossible. Option C is incorrect because rule-based filtering might remove important patterns and doesn't guarantee privacy protection levels required by CCPA. Option D is incorrect because manual anonymization is error-prone, doesn't scale, and may not meet mathematical privacy guarantees. Differential privacy emerges as the gold standard for CCPA compliance in machine learning. This technique adds carefully calibrated statistical noise to data in a way that preserves overall patterns while making it mathematically impossible to identify individuals. Think of it like adding static to a radio signal, where you can still hear the song but can't identify individual instruments. The beauty of differential privacy is that it provides provable privacy guarantees with precise mathematical bounds. Complete deletion prevents any model training, rule-based filtering might remove important patterns, and manual anonymization is error-prone and doesn't scale. Differential privacy maintains the statistical properties needed for effective model training, while ensuring that no individual's data can be reverse engineered from the model. 20. A robot vacuum needs to clean an entire house efficiently without getting stuck. Which combination of agent type and environment characteristic would be most suitable? A. Simple reflex fully observable. B. Model-based partially observable. C. Software agent dynamic environment. D. Learning agent unobservable environment. Do you know the answer? Correct answer, B. Model-based partially observable. Explanation. Option B is correct because model-based agents maintain internal maps of the house while handling partial observability, since the robot cannot see all rooms simultaneously. Option A is incorrect because simple reflex agents cannot plan efficient cleaning routes or remember which areas have been cleaned. Option C is incorrect because software agents lack physical actuators needed for vacuum cleaning and movement through the house. Option D is incorrect because completely unobservable environments would prevent any navigation, making cleaning impossible for the robot. Robot vacuums beautifully demonstrate why model-based agents excel in partially observable environments. The robot can only see what's immediately in front of its sensors, not the entire house layout simultaneously. A model-based agent builds and maintains an internal map of the house as it explores, remembering where furniture is located, which areas have been cleaned, and optimal paths between rooms. This internal model compensates for partial observability by storing information about unseen areas. Simple reflex agents would repeatedly clean the same visible area, software agents lack physical capabilities, and completely unobservable environments would make navigation impossible. The model-based approach enables efficient cleaning patterns even when the robot can't see the whole house at once. 21. Your team discovers that your recommendation system creates filter bubbles, limiting user exposure to diverse content. Which AI ethical concern does this represent, and what's the impact? A. Privacy violation exposure. B. Algorithmic bias reinforcement. C. Transparency lacking explanation. D. Accountability avoiding responsibility. Can you guess the answer? Correct answer, B. Algorithmic bias reinforcement. Explanation. Option B is correct because filter bubbles represent algorithmic bias that reinforces existing preferences, limiting exposure to diverse perspectives and potentially polarizing users. Option A is incorrect because filter bubbles don't violate privacy, but rather over-personalize based on known preferences and behaviors. Option C is incorrect because transparency issues relate to explaining decisions, while filter bubbles are about the consequences of personalization. Option D is incorrect because accountability concerns who is responsible for outcomes, not the creation of information echo chambers. Let's dive into how filter bubbles represent a form of algorithmic bias that shapes our digital experiences. When recommendation systems create filter bubbles, they're not violating privacy or lacking transparency, but rather creating an invisible bias that reinforces existing preferences. Imagine being in a room where the walls gradually become mirrors, reflecting only what you already like back at you. The algorithm learns your preferences and keeps serving similar content, creating an echo chamber that limits exposure to diverse perspectives. This algorithmic bias doesn't just affect individual users. It can polarize entire communities by preventing the cross-pollination of ideas. The result is users becoming trapped in increasingly narrow content loops, missing important information and alternative viewpoints that could broaden their understanding. 22. A logistics company needs to optimize delivery routes considering traffic patterns, weather, and package priorities. Which AI approach would handle these multiple uncertain factors most effectively? A. Deterministic planning algorithm. B. Bayesian inference system. C. Simple reflex rules. D. Semantic network mapping. Do you know the answer? Correct answer, B. Bayesian inference system. Explanation. Option B is correct because Bayesian inference updates probability distributions as new information arrives, perfect for handling multiple uncertain factors in route optimization. Option A is incorrect because deterministic planning cannot handle the inherent uncertainty in traffic patterns and weather conditions effectively. Option C is incorrect because simple reflex rules cannot process complex interactions between multiple factors or adapt to changing conditions. Option D is incorrect because semantic networks represent relationships between concepts, but don't handle probabilistic reasoning for uncertain factors. Bayesian inference shines when dealing with multiple, uncertain factors in logistics optimization. This approach treats each factor like traffic, weather, and package priority as probability distributions that update with new information. Picture a delivery system that starts the day with historical probabilities: 60% chance of normal traffic, 30% chance of rain. As real-time data flows in, Bayesian inference updates these probabilities, perhaps learning that an accident increased traffic delay probability to 90%. Unlike deterministic planning that assumes fixed conditions, or simple rules that can't adapt, Bayesian systems continuously refine their understanding. They calculate the most probable scenarios by combining all uncertain factors, enabling dynamic route optimization that adapts to changing conditions throughout the day. 23. Your image classification model performs well on training data but poorly on real-world images. Which data pre-processing technique would least likely solve this generalization problem? A. Dataset augmentation techniques. B. Removing static columns. C. Cross-validation implementation. D. Transfer learning application. Can you guess the answer? Correct answer, B. Removing static columns. Explanation. Option B is correct because removing static columns helps with tabular data but doesn't address image generalization issues like variation in lighting or angles. Option A is incorrect because dataset augmentation with rotations, scaling, and flipping directly improves model generalization to real-world variations. Option C is incorrect because cross-validation helps identify overfitting issues and improves generalization through better training evaluation. Option D is incorrect because transfer learning leverages pre-trained models that have already learned robust features from diverse images. Understanding why removing static columns won't help image generalization reveals important pre-processing principles. Static columns are a tabular data concept where a column has the same value for every row, providing no useful information. But images don't have columns in this sense. They have pixels arranged in a grid. The generalization problem occurs when models memorize training images instead of learning robust features. Dataset augmentation directly addresses this by creating variations through rotation, flipping, and color changes, teaching the model invariance to these transformations. Cross-validation helps detect overfitting, while transfer learning provides pre-trained robust features. Removing static columns is simply the wrong tool for the wrong data type, like using a hammer on a screw. 24. An emergency response system must coordinate ambulances, hospitals, and dispatch centres during disasters. Which knowledge representation method best captures these complex interdependencies? A. Semantic network representation. B. Propositional logic rules. C. Linear temporal logic. D. Modal logic system. Do you know the answer? Correct answer, A. Semantic network representation. Explanation. Option A is correct, because semantic networks visually represent complex relationships between entities with nodes and edges, ideal for emergency response coordination. Option B is incorrect because propositional logic handles true-false statements, but struggles with complex multi-entity relationship representations. Option C is incorrect because linear temporal logic focuses on sequence timing rather than spatial and resource interdependencies. Option D is incorrect because modal logic deals with necessity and possibility, not the practical relationships between emergency resources. Semantic networks excel at representing complex emergency response coordination because they naturally capture relationships. In disaster scenarios, the connections between ambulances, hospitals, and dispatch centres are just as important as the entities themselves. Picture a web where nodes represent resources like available ambulances or hospital bed counts, while edges show relationships like assigned to or can reach in 5 minutes. This visual representation allows the system to quickly trace paths, find nearest available resources, and understand dependencies. Propositional logic handles true-false statements, but struggles with relationships. Temporal logic focuses on timing rather than connections. And modal logic deals with possibilities rather than practical resource coordination that semantic networks provide. 25. Your startup wants to create realistic product descriptions from basic specifications. Which NLP architecture would best generate coherent, contextually appropriate marketing content? A. Bag of words model. B. Transformer architecture. C. Rule-based grammar. D. One-hot encoding. Can you guess the answer? Correct answer, B. Transformer architecture. Explanation: option B is correct because transformers use self-attention mechanisms to generate coherent, contextually rich text by understanding relationships between all input elements. Option A is incorrect because bag of words models only analyze word frequency without generating new coherent text sequences. Option C is incorrect because rule-based grammars produce rigid, template-like text, lacking the creative flexibility needed for marketing. Option D is incorrect because one-hot encoding is a representation method for input data, not a text generation architecture. This is a critical concept for multi-robot systems, so let's dig into why learning agents in multi-agent settings work best. In a warehouse with multiple robots and partial observability, each robot can only see its immediate surroundings, not the entire warehouse. When generating product descriptions, the self-attention mechanism ensures that adjectives properly relate to product features, maintaining coherence throughout. Imagine having dozens of people each responsible for one word, but they can all talk to each other simultaneously to agree on the story. Bag of words just counts frequencies without generation capability. Rule-based grammars produce rigid templates, and one-hot encoding merely represents input. Only transformers combine the contextual understanding with creative flexibility needed for compelling marketing copy. 26. A warehouse needs to track inventory levels that change continuously throughout the day with multiple robots updating records simultaneously. Which environment characteristics describe this system? A. Discrete static single. B. Continuous dynamic multi-agent. C. Episodic deterministic sequential. D. Discrete dynamic single. Do you know the answer? Correct answer, B. Continuous dynamic multi-agent. Explanation: option B is correct because inventory levels change continuously, the environment changes during operation, and multiple robots act as independent agents updating records. Option A is incorrect because inventory tracking involves multiple robots and continuous changes, not discrete static single-agent systems. Option C is incorrect because inventory management is ongoing rather than episodic, and multiple robot interactions create non-deterministic outcomes. Option D is incorrect because the system involves multiple robots as agents and continuous rather than discrete state changes. Warehouse inventory tracking perfectly illustrates continuous dynamic multi-agent environments. Inventory levels aren't discrete units jumping from 10 to 9, but continuous values changing gradually as items are partially consumed or added. The environment is dynamic because these levels change constantly throughout operations, not just when the system observes them. Multiple robots act as independent agents, each updating records simultaneously without central coordination. This creates a complex system where Robot A might be adding stock, while Robot B removes items and Robot C conducts inventory counts, all in real time. Understanding these characteristics is crucial for designing systems that maintain accurate inventory without conflicts or race conditions between agents. 27. Your facial recognition system must work in varying lighting conditions, from bright daylight to dim indoor settings. Which computer vision technique would best ensure consistent performance? A. Active sensing only. B. Dataset augmentation approach. C. Passive sensing exclusively. D. Object model matching. Can you guess the answer? Correct answer, B. Dataset augmentation approach. Explanation. Option B is correct because dataset augmentation creates training variations with different lighting conditions, helping the model generalize across illumination changes. Option A is incorrect because active sensing emits signals, which does not solve the fundamental lighting variation problem in recognition. Option C is incorrect because passive sensing alone does not address the need for training data covering various lighting conditions. Option D is incorrect because object models assume consistent features, but lighting changes dramatically alter facial appearance in images. Dataset augmentation emerges as the key solution for handling lighting variations in facial recognition. Different lighting conditions dramatically change how faces appear in images, with shadows, highlights, and color temperatures creating vastly different representations of the same person. Dataset augmentation synthetically creates training examples under various lighting conditions, teaching the model that these variations still represent the same face. It's like showing someone hundreds of photos of the same person at different times of day, indoors, outdoors, under fluorescent lights, and in candlelight. Active sensing won't help because it's about emitting signals, not processing light variations. The model learns lighting invariance through exposure to augmented variations during training. 28. A bank's loan approval system must explain its decisions to comply with regulations. Which machine learning approach would best balance accuracy with interpretability requirements? A. Deep neural network. B. Decision tree algorithm. C. Unsupervised clustering method. D. Black box ensemble. Do you know the answer? Correct answer, B. Decision tree algorithm. Explanation. Option B is correct because decision trees provide clear, traceable paths from input features to decisions, making them ideal for regulatory compliance requiring explanations. Option A is incorrect because deep neural networks are notoriously difficult to interpret, making regulatory compliance explanations nearly impossible. Option C is incorrect because unsupervised clustering doesn't provide specific approval decisions and lacks clear explanation paths. Option D is incorrect because black box ensembles prioritize accuracy over interpretability, failing regulatory requirements for transparent decisions. Decision trees provide the perfect balance of accuracy and interpretability for regulated loan approvals. In banking, every loan decision must be explainable to regulators and applicants, especially when denying credit. The generalization problem occurs when models memorize training images instead of learning robust features. Dataset augmentation directly addresses this by creating variations through rotation, flipping, and color changes, teaching the model invariance to these transformations. Neural networks, despite high accuracy, are black boxes where decisions emerge from millions of weighted connections impossible to explain. Clustering doesn't make approval decisions, and ensemble methods sacrifice interpretability for accuracy. Decision trees satisfy both legal requirements and business needs. 29. Your company's chatbot needs to understand customer intent from messages containing typos, slang, and incomplete sentences. Which text pre-processing technique is most critical? A. Perfect tokenization precision. B. Robust embedding generation. C. Strict grammar enforcement. D. Exact pattern matching. Can you guess the answer? Correct answer. B. Robust embedding generation. Explanation. Option B is correct because word embeddings capture semantic meaning even with variations, understanding that you, and you represent the same concept. Option A is incorrect because perfect tokenization would fail on typos and slang, breaking on non-standard text patterns. Option C is incorrect because enforcing strict grammar would reject most casual customer messages containing natural language variations. Option D is incorrect because exact pattern matching cannot handle the variations, typos, and informal language common in customer messages. Robust word embeddings are essential for understanding messy customer messages with typos and slang. Word embeddings capture semantic meaning in dense vectors, understanding that variations like you, and you all represent the same concept despite different spellings. These embeddings learn from context, recognizing that gar8 means great because they appear in similar sentence positions. Think of embeddings as understanding the soul of words rather than their exact spelling. Perfect tokenization would break on non-standard text, strict grammar would reject casual messages, and exact pattern matching fails on any variation. Robust embeddings handle the beautiful chaos of human communication, understanding intent despite imperfect expression. 30. A research team needs to predict protein folding patterns from amino acid sequences. Which combination of techniques would best handle this sequential data with long-range dependencies? A. CNN with RNN, B. LSTM with attention, C. Simple RNN only, D. Transformer exclusively. Do you know the answer? Correct answer, B. LSTM with attention. Explanation. Option B is correct because LSTMs handle long sequences effectively, while attention mechanisms identify important long-range dependencies between distant amino acids. Option A is incorrect because CNNs are designed for spatial patterns in images, not sequential dependencies in protein sequences. Option C is incorrect because simple RNNs suffer from vanishing gradients in long sequences, unable to capture distant amino acid interactions. Option D is incorrect because while transformers are powerful, LSTM with attention is more proven for biological sequence analysis. Protein folding prediction showcases why combining LSTMs with attention mechanisms is so powerful. Proteins are long sequences where amino acids far apart in the chain can interact in 3D space, creating long-range dependencies. LSTMs excel at processing these long sequences without losing information to vanishing gradients, maintaining a memory of the entire chain. The attention mechanism adds another layer, identifying which distant amino acids are most likely to interact, like highlighting specific words in a long document that relate to each other. CNNs miss sequential nature, simple RNNs can't handle the length, and transformers alone, while powerful, aren't as proven in biological sequences as LSTM attention combinations that dominate protein structure prediction. 31. Your autonomous drone must navigate through a forest with unpredictable wind patterns and moving branches. Which agent-environment interaction best describes this scenario's primary challenge? A. Fully observable deterministic, B. Partially observable stochastic, C. Discrete episodic static, D. Continuous sequential known. Can you guess the answer? Correct answer, B. Partially observable stochastic. Explanation. Option B is correct because the drone cannot observe all wind patterns and branch movements, while these factors change randomly, creating stochastic partial observability. Option A is incorrect because forest environments are neither fully observable nor deterministic due to hidden obstacles and random wind. Option C is incorrect because drone navigation is continuous and dynamic with the environment constantly changing, not discrete or static. Option D is incorrect because the forest environment is unknown with unpredictable elements, not a known environment with predictable rules. Forest drone navigation exemplifies the challenges of partially observable stochastic environments. The drone sensors can't see through dense tree canopy or around obstacles, creating partial observability where hidden branches could appear suddenly. The environment is stochastic because wind patterns change randomly and unpredictably, branches move without warning, and weather conditions vary moment to moment. These aren't deterministic patterns the drone can learn, but truly random events requiring constant adaptation. It's not discrete with fixed positions, but continuous with infinite possible locations, and definitely not static as everything moves constantly. This combination makes forest navigation one of the most challenging environments for autonomous systems. 32. The content moderation system incorrectly flags legitimate educational content about historical events as harmful. Which approach would best reduce these false positives? A. Increased detection sensitivity. B. Context-aware processing implementation. C. Stricter keyword filtering. D. Binary classification only. Do you know the answer? Correct answer, B. Context-aware processing implementation. Explanation. Option B is correct because context-aware processing understands that identical terms have different meanings in educational versus harmful contexts, reducing false positives. Option A is incorrect because increasing sensitivity would create more false positives, flagging even more legitimate educational content incorrectly. Option C is incorrect because stricter keyword filtering would increase false positives by ignoring the educational context of sensitive terms. Option D is incorrect because binary classification lacks nuance to distinguish between educational and harmful uses of similar content. Context-aware processing is the key to reducing false positives in content moderation. The same words or images can be harmful or educational depending entirely on context. Historical footage of conflicts is educational in documentaries, but could be flagged as violent content without context. Medical anatomy images are educational for students, but might trigger basic content filters. Context-aware systems analyze surrounding text, metadata, source credibility and usage patterns to understand intent. Increasing sensitivity would flag even more legitimate content. Stricter filtering ignores context entirely, and binary classification lacks the nuance to distinguish between a history lesson and harmful content. Context transforms moderation from blind pattern matching to intelligent understanding. 33. Your team needs to protect user privacy while training a collaborative filtering recommendation system across multiple companies. Which technique best achieves this goal? A. Centralized data collection. B. Federated learning approach. C. Complete anonymization only. D. Manual privacy review. Can you guess the answer? Correct answer, B. Federated learning approach. Explanation. Option B is correct because federated learning trains models on distributed data without centralizing it, preserving privacy while enabling collaborative learning across companies. Option A is incorrect because centralized collection violates privacy by aggregating sensitive user data from multiple companies in one location. Option C is incorrect because anonymization alone doesn't prevent data centralization and may still allow re-identification through combined data sets. Option D is incorrect because manual review doesn't scale and cannot guarantee mathematical privacy preservation across collaborative training. Bayesian inference shines when dealing with multiple, uncertain factors in logistics optimization. This approach treats each factor like traffic, weather, and package priority as probability distributions that update with new information, the model travels to the data, trains locally, and only model updates are shared, never raw user information. Imagine teachers grading exams in separate rooms, then only sharing grading insights, never showing actual student answers. This approach enables companies to benefit from collective learning while maintaining complete data sovereignty. Centralization violates privacy. Anonymization alone doesn't prevent centralization risks, and manual review can't scale. Federated learning provides mathematical privacy guarantees while enabling powerful collaborative AI. 34. An agricultural monitoring system uses satellite imagery to detect crop diseases before visible symptoms appear. Which computer vision component is most critical for early detection? A. Active sensing capability. B. Feature extraction precision. C. Object model library. D. Reconstruction accuracy. Do you know the answer? Correct answer, B. Feature extraction precision. Explanation: option B is correct because precise feature extraction identifies subtle spectral changes in crops, indicating disease before visible symptoms manifest to human observers. Option A is incorrect because satellites use passive sensing to capture reflected light, not active sensing with emitted signals. Option C is incorrect because object models assume known patterns, but early disease detection requires identifying novel, subtle changes. Option D is incorrect because reconstruction builds three-dimensional models from images, while disease detection needs pattern analysis in existing imagery. Feature extraction precision enables early disease detection in crops through subtle spectral changes. Before visible symptoms appear, diseased plants reflect light differently in specific wavelengths invisible to human eyes. Precise feature extraction identifies these subtle spectral signatures, like detecting a whisper in a crowded room. The system analyzes reflectance patterns across multiple spectral bands, identifying minute changes in chlorophyll content, water stress, or cellular structure that indicate disease onset. Satellites use passive sensing capturing reflected sunlight, not active sensing. Object models assume known patterns, but early disease creates novel signatures. Reconstruction builds 3D models which aren't needed. Only precise feature extraction can identify these early warning signs before crop damage occurs. 35. Your recommendation engine must balance exploration of new content with exploitation of known user preferences. Which reinforcement learning concept best addresses this trade-off? A. Q-learning values only. B. Inverse reinforcement learning. C. Problem generator component. D. Model-based planning. Can you guess the answer? Correct answer, C. Problem generator component. Explanation: option C is correct because the problem generator suggests exploratory actions to discover new preferences, while the performance element exploits known successful recommendations. Option A is incorrect because Q-learning focuses on learning action values but doesn't inherently balance exploration with exploitation. Option B is incorrect because inverse reinforcement learning infers reward functions from observations, not balancing exploration and exploitation. Option D is incorrect because model-based planning uses environment models for decision-making, but doesn't specifically address exploration-exploitation trade-off. The problem generator component specifically addresses exploration-exploitation trade-off in recommendation systems, while the performance element exploits known preferences by recommending similar content users enjoyed before. The problem generator suggests exploratory actions to discover new interests. It's like a friend who knows you love Italian food, but suggests trying Thai cuisine occasionally. This component proposes recommendations outside the user's comfort zone, preventing filter bubbles while potentially discovering new favorites. Neural networks, despite high accuracy, are black boxes where decisions emerge from millions of weighted connections impossible to explain. Clustering doesn't make approval decisions, and ensemble methods sacrifice interpretability for accuracy. Decision trees satisfy both legal requirements and business needs. 36. A medical imaging AI consistently performs worse on certain equipment manufacturers' scans. Which data quality dimension is primarily affecting the model's performance? A. Completeness of records. B. Uniformity across sources. C. Temporal relevance factor. D. Accuracy of labels. Do you know the answer? Correct answer: B. Uniformity across sources. Explanation: Option B is correct because lack of uniformity between different manufacturers' imaging formats and characteristics causes performance variations across equipment types. Option A is incorrect because the issue isn't missing data, but rather inconsistent data representation across different equipment manufacturers. Option C is incorrect because temporal relevance relates to data timeliness, not equipment-specific performance variations in medical imaging. Option D is incorrect because label accuracy affects overall performance equally, not selective degradation on specific equipment types. Equipment-specific performance variations in medical AI point directly to uniformity issues across data sources. Different manufacturers use varying image formats, resolutions, contrast settings, and processing algorithms, creating inconsistent data representations of the same medical conditions. Imagine trying to compare photos taken by different cameras with different settings. The same scene looks different in each. This lack of uniformity means the AI learns equipment-specific patterns rather than true medical features. Completeness would affect missing data equally across equipment, temporal relevance relates to data age, and accuracy affects all equipment similarly. Only uniformity explains why the model works well on familiar equipment, but fails on different manufacturers' outputs. 37. Your natural language model needs to understand that bank means financial institution in one sentence and river edge in another. Which linguistic concept does this represent? A. Syntactic categorization only. B. Semantic ambiguity resolution. C. Grammatical structure parsing. D. Tokenization granularity. Can you guess the answer? Correct answer: B. Semantic ambiguity resolution. Explanation: Option B is correct because semantic ambiguity occurs when words have multiple meanings, requiring context-based resolution to determine the intended interpretation. Option A is incorrect because syntactic categorization groups words by grammatical function, not meaning disambiguation in different contexts. Option C is incorrect because grammatical parsing analyzes sentence structure but doesn't resolve meaning ambiguity of individual words. Option D is incorrect because tokenization granularity affects how text is split into units, not understanding multiple word meanings. Equipment-specific performance variations in medical AI point directly to uniformity issues across data sources. Different manufacturers use varying image formats, resolutions, contrast settings, and processing algorithms, creating inconsistent data representations of the same medical conditions. Imagine trying to compare photos taken by different cameras with different settings. The same scene looks different in each. This lack of uniformity means the AI learns equipment-specific patterns rather than true medical features. Completeness would affect missing data equally across equipment, temporal relevance relates to data age, and accuracy affects all equipment similarly. Only uniformity explains why the model works well on familiar equipment, but fails on different manufacturers' outputs. 38. A delivery robot operating in a busy mall must avoid both stationary obstacles and moving shoppers. Which planning approach would be most effective? A. Static path planning. B. Reactive obstacle avoidance. C. Offline route optimization. D. Deterministic scheduling. Do you know the answer? Correct answer, B. Reactive obstacle avoidance. Explanation. Option B is correct because reactive obstacle avoidance responds immediately to dynamic obstacles like moving shoppers while navigating toward delivery goals in real time. Option A is incorrect because static planning cannot handle moving shoppers and the constantly changing mall environment effectively. Option C is incorrect because offline optimization cannot adapt to real-time changes in shopper positions and mall conditions. Option D is incorrect because deterministic scheduling assumes predictable conditions, which is impossible with random shopper movements in malls. Reactive obstacle avoidance perfectly suits the dynamic mall environment, where shoppers move unpredictably. Unlike static planning that assumes fixed paths, reactive avoidance responds instantly to sudden changes like a child running across the robot's path or shoppers stopping abruptly. The robot continuously senses its immediate environment and adjusts trajectory in real time, like a skilled driver navigating traffic. Static planning would require constant replanning as shoppers move. Offline optimization can't handle real-time changes, and deterministic scheduling assumes predictable patterns that don't exist in malls. Reactive avoidance provides the immediate response needed for safe navigation, while still progressing toward delivery goals through dynamic adjustment. 39. Your fraud detection system has many more legitimate transactions than fraudulent ones in training data. Which technique best addresses this class imbalance problem? A. Removing minority class. B. Weighted loss functions. C. Ignoring imbalance completely. D. Using accuracy metric. Can you guess the answer? Correct answer, B. Weighted loss functions. Explanation. Option B is correct because weighted loss functions assign higher penalties for misclassifying minority class fraudulent transactions, addressing the imbalance effectively. Option A is incorrect because removing the minority class would eliminate all fraud examples, making fraud detection impossible. Option C is incorrect because ignoring imbalance causes models to predict only legitimate transactions, missing actual fraud cases. Option D is incorrect because accuracy metrics are misleading with imbalanced data, showing high scores while missing minority fraud cases. Let's explore the critical relationship between fairness and dataset augmentation in AI ethics. When facial recognition performs poorly on certain groups, it violates the fairness principle, creating discriminatory outcomes. This isn't about privacy or transparency, but about equal treatment. Weighted loss functions assign much higher penalties for misclassifying the rare fraudulent transactions, forcing the model to pay attention to these critical cases. It's like a teacher giving more points to hard questions on an exam. Removing minority class eliminates what we're trying to detect. Ignoring imbalance leads to useless models. And accuracy metrics lie about performance. Weighted loss functions rebalance the learning process without losing any data. 40. A smart home system needs to learn user preferences for temperature, lighting, and music without explicit programming. Which learning paradigm best fits this requirement? A. Supervised learning only. B. Reinforcement learning approach. C. Rule-based programming. D. Offline batch processing. Do you know the answer? Correct answer, B. Reinforcement learning approach. Explanation. Option B is correct because reinforcement learning learns optimal preferences through trial and rewards based on user satisfaction without explicit preference programming. Option A is incorrect because supervised learning requires labelled examples of correct preferences, which aren't available without explicit programming. Option C is incorrect because rule-based programming requires explicit programming of preferences, contradicting the requirement for learning. Option D is incorrect because offline batch processing describes when learning occurs, not how preferences are learned without programming. Alright, let's break down the core concept behind this question about learning approaches in AI. When we have limited labelled data, but abundant unlabelled data, like in medical imaging for rare diseases, we need a smart strategy. When the system sets temperature to 70 degrees, and you adjust it to 68, it receives negative feedback. When lighting dims automatically at sunset and you leave it, positive reinforcement occurs. Over time, the system learns your preferences through these interactions without anyone programming specific rules. Supervised learning needs labelled examples that don't exist. Rule-based systems require explicit programming, and offline batch processing describes when, not how learning occurs. Reinforcement learning discovers optimal preferences through experience. 41. Your company's sentiment analysis model, trained on product reviews, performs poorly on social media posts. Which factor best explains this performance degradation? A. Algorithm selection error. B. Domain shift problem. C. Overfitting prevention failure. D. Feature engineering mistake. Can you guess the answer? Correct answer, B. Domain shift problem. Explanation. Option B is correct because domain shift occurs when models trained on formal product reviews encounter different language patterns in casual social media posts. Option A is incorrect because the algorithm works well on product reviews, indicating the algorithm choice is not the fundamental problem. Option C is incorrect because overfitting would show good training performance but poor test performance within the same domain. Option D is incorrect because feature engineering issues would affect performance on both product reviews and social media posts equally. Sybil attacks represent a fundamental security threat, exploiting identity uncertainty in AI systems. Named after the famous case of multiple personality disorder, these attacks involve creating numerous fake identities to manipulate system behavior. Social media posts operate in an entirely different linguistic universe, with hashtags, emojis, abbreviations, and casual language the model has never seen. It's like training a translator on Shakespeare, then asking them to translate modern text messages. The algorithm works fine, it's not overfitting to training data, and features are extracted correctly. The fundamental issue is that the model learned patterns from one domain that don't exist in another, creating a shift that degrades performance. 42. An autonomous vehicle's perception system must distinguish between a real pedestrian and a billboard showing a person. Which visual processing capability is most critical? A. Color detection accuracy. B. Motion pattern analysis. C. Edge detection precision. D. Texture recognition ability. Do you know the answer? Correct answer, B. Motion pattern analysis. Explanation. Option B is correct because motion patterns differentiate static billboard images from real pedestrians who exhibit natural movement even when standing still. Option A is incorrect because both real pedestrians and billboard images can have identical color patterns, making discrimination impossible. Option C is incorrect because edge detection identifies boundaries in both real pedestrians and billboard images without distinguishing them. Option D is incorrect because modern billboards can reproduce textures realistically, making texture alone insufficient for discrimination. Motion pattern analysis is the critical capability for distinguishing real pedestrians from billboard images. Even when standing still, real humans exhibit micro-movements like breathing, slight swaying, or head turns that static images never display. The perception system tracks these subtle motion signatures over time, building confidence that movement indicates a living person. A billboard, no matter how realistic, remains perfectly still even in wind since the image itself doesn't move. Color detection fails because both can have identical colors, edge detection finds boundaries in both, and texture recognition is fooled by high-resolution printing. Only motion patterns provide the definitive signal, separating static representations from actual humans requiring collision avoidance. 43. Your text generation model produces grammatically correct but factually incorrect statements about historical events. Which component needs improvement to address this issue? A. Tokenization process only. B. Knowledge grounding mechanism. C. Syntactic parsing rules. D. Word embedding quality. Can you guess the answer? Correct answer, B. Knowledge grounding mechanism. Explanation. Option B is correct because knowledge grounding connects generated text to factual information sources, preventing grammatically correct but factually wrong statements. Option A is incorrect because tokenization affects text segmentation, not the factual accuracy of the generated content about historical events. Option C is incorrect because syntactic parsing ensures grammatical correctness, which is already working properly in the model. Option D is incorrect because word embeddings capture semantic relationships, but don't ensure the factual accuracy of generated statements. Knowledge grounding mechanisms are essential for preventing factually incorrect text generation. While language models can produce grammatically perfect sentences, they may fabricate information without connection to real facts. The environment is dynamic because these levels change constantly throughout operations, not just when the system observes them. Multiple robots act as independent agents, each updating records simultaneously without central coordination. The agent might make hundreds of decisions before receiving any reward signal, creating a credit assignment problem. Unlike continuous action spaces or deterministic outcomes which actually simplify learning. Sparse rewards force agents to explore extensively and maintain long-term memory of action sequences. 44. A hospital AI system must prioritize emergency room patients based on symptoms, vital signs, and medical history. Which decision-making framework ensures ethical patient treatment? A. Pure optimization algorithm. B. Fairness-aware classification. C. Cost minimization only. D. Speed maximization approach. Do you know the answer? Correct answer, B. Fairness-aware classification. Explanation. Option B is correct because fairness-aware classification ensures medical urgency drives prioritization without bias based on demographics or socioeconomic factors. Option A is incorrect because pure optimization might prioritize based on factors like treatment cost rather than medical necessity. Option C is incorrect because cost minimization could deny treatment to expensive cases regardless of medical urgency or need. Option D is incorrect because speed maximization might prioritize quick cases over critically urgent but complex medical emergencies. Fairness-aware classification ensures emergency room prioritization based on medical need, not demographics. Standard optimization might inadvertently prioritize patients based on factors correlating with better outcomes or lower costs, creating systematic bias. Fairness-aware systems explicitly check that urgency drives decisions regardless of age, race, insurance status, or socioeconomic factors. A homeless person with chest pain receives the same priority as a CEO with identical symptoms. Pure optimization could favor profitable cases. Cost minimization might deprioritize expensive treatments. And speed maximization could skip complex urgent cases for quick simple ones. Fairness-aware classification embeds ethical principles directly into the algorithm, ensuring medical urgency remains the sole criterion. 45. Your speech recognition system struggles with users who have strong regional accents. Which data management strategy would best improve inclusivity? A. Filter accent data by stratified sampling collection. C. Majority accent focus. D. Standardization enforcement. Can you guess the answer? Correct answer, B. Stratified sampling collection. Explanation. Option B is correct because stratified sampling ensures proportional representation of different accents in training data, improving recognition across all user groups. Option A is incorrect because filtering accent data would exclude the very users the system needs to serve better. Option C is incorrect because focusing on majority accents perpetuates the exclusion of regional accent speakers from system benefits. Option D is incorrect because enforcing standardization ignores natural language variation and doesn't improve accent recognition capabilities. Stratified sampling collection is the key to inclusive speech recognition across all accents. This method ensures proportional representation by deliberately collecting samples from each accent group rather than accepting whatever data comes naturally. If 10% of users have Southern accents, stratified sampling ensures 10% of training data represents that accent. It's like ensuring every voice in a choir gets heard, not just the loudest ones. Filtering accents excludes users entirely. Focusing on majority perpetuates bias, and standardization attempts to force conformity. Stratified sampling celebrates linguistic diversity while ensuring the technology serves everyone equally, transforming exclusive systems into inclusive ones. 46. A trading algorithm must decide whether to execute trades based on multiple, uncertain market indicators. Which reasoning method best handles this uncertainty? A. Deterministic rule application. B. Joint probability distribution. C. Binary decision tree. D. Static threshold checking. Do you know the answer? Correct answer, B. Joint probability distribution. Explanation. Option B is correct because joint probability distributions model relationships between multiple uncertain indicators, enabling informed trading decisions under uncertainty. Option A is incorrect because deterministic rules cannot handle the inherent uncertainty and correlations in market indicators effectively. Option C is incorrect because binary decision trees make hard splits without capturing probabilistic relationships between uncertain indicators. Option D is incorrect because static thresholds ignore the dynamic relationships and uncertainty inherent in market indicator interactions. Joint probability distributions excel at modelling multiple uncertain market indicators for trading decisions. Markets involve numerous correlated uncertainties where oil prices affect transportation stocks, interest rates influence bond yields, and currency fluctuations impact international trade. Joint probability distributions capture these complex relationships, showing not just individual probabilities, but how indicators influence each other. When oil rises, the distribution shows increased probability of airline stock decline. Deterministic rules can't handle uncertainty. Binary trees make hard cuts ignoring probabilities. And static thresholds miss dynamic relationships. Joint distributions model the full complexity of interconnected market uncertainties, enabling sophisticated trading strategies. 47. Your IoT sensor network generates massive amounts of data, with occasional sensor malfunctions creating anomalies. Which pre-processing step is most critical before model training? A. Feature creation first. B. Normalization immediately. C. Outlier detection removal. D. Dimensionality reduction only. Can you guess the answer? Correct answer, C. Outlier detection removal. Explanation. Option C is correct because removing outliers from sensor malfunctions prevents these anomalies from skewing model training and degrading prediction accuracy. Option A is incorrect because creating features from data containing sensor malfunctions would propagate errors throughout the feature set. Option B is incorrect because normalizing data with outliers would distort the scale based on erroneous malfunction values. Option D is incorrect because dimensionality reduction without removing outliers would embed malfunction patterns into reduced representations. Outlier detection and removal is the critical first step for IoT sensor networks with malfunctions. Sensor malfunctions create extreme values that can completely distort analysis if not removed first. The bias emerges from training data that lacks diversity, causing the system to learn features predominantly from overrepresented groups. Dataset augmentation specifically addresses this by artificially expanding the training data to include more diverse examples. Creating features from contaminated data spreads the error. Normalization with outliers distorts scales, and dimensionality reduction embeds bad data into compressed representations. Only after cleaning can we trust the data for model training. 48. A language translation system needs to preserve meaning while handling idioms that don't translate literally between languages. Which approach best maintains semantic accuracy? A. Word-for-word translation. B. Contextual embedding transfer. C. Grammatical structure. Matching. D. Dictionary lookup only. Do you know the answer? Correct answer. B. Contextual embedding transfer. Explanation. Option B is correct because contextual embeddings capture idiomatic meanings in the source language and find semantically equivalent expressions in the target language. Option A is incorrect because word-for-word translation of idioms produces nonsensical results that lose the intended meaning entirely. Option C is incorrect because matching grammatical structures doesn't preserve meaning when idioms have different structures across languages. Option D is incorrect because dictionary lookups provide literal translations that miss the figurative meaning of idiomatic expressions. Contextual embedding transfer is the solution for preserving meaning in idiom translation. Idioms like "it's raining cats and dogs" can't be translated word for word into "il pleut des chats et des chiens" without losing all meaning. Contextual embeddings capture the semantic essence of heavy rain, then find the equivalent expression in the target language, perhaps "il pleut des cordes." The embedding understands the idiom means intense precipitation, not falling animals, and searches for culturally appropriate equivalents. Word-for-word translation produces nonsense, grammatical matching ignores meaning, and dictionaries give literal definitions, missing figurative intent. Contextual embeddings bridge the semantic gap between languages' different ways of expressing the same concepts. 49. Your quality control system uses computer vision to detect manufacturing defects. Which approach would best handle defects that vary significantly in appearance? A. Fixed template matching. B. Ensemble detection methods. C. Single threshold setting. D. Static rule application. Can you guess the answer? Correct answer. B. Ensemble detection methods. Explanation. Option B is correct because ensemble methods combine multiple detection approaches to identify diverse defect types that no single method could catch comprehensively. Option A is incorrect because fixed templates cannot match the significant variation in defect appearances across different types. Option C is incorrect because single thresholds miss defects that fall outside predetermined ranges for specific defect types. Option D is incorrect because static rules cannot adapt to the unpredictable variety of manufacturing defect manifestations. Insurance claim prediction perfectly illustrates the distinction between classification and regression in machine learning. When predicting claim likelihood, we're answering a yes or no question. Will this customer file a claim? This binary outcome makes it a classification problem. Ensemble methods combine multiple specialized detectors, like having a team of experts each looking for specific problems. One detector might excel at finding surface scratches, while another identifies color inconsistencies. By combining their outputs, the ensemble catches defects that any single method would miss. Fixed templates can't match varying defects. Single thresholds miss defects outside specific ranges, and static rules can't adapt to new defect types. Ensemble methods provide comprehensive quality control. 50. An educational platform wants to personalize learning paths while avoiding creating knowledge gaps. Which AI approach best balances personalization with comprehensive coverage? A. Pure exploration strategy. B. Constrained optimization approach. C. Random content selection. D. Fixed curriculum only. Do you know the answer? Correct answer, B. Constrained optimization approach. Explanation. Option B is correct, because constrained optimization personalizes within boundaries, ensuring all essential topics are covered while adapting to individual learning styles. Option A is incorrect because pure exploration might skip fundamental concepts needed for advanced topics, creating knowledge gaps. Option C is incorrect because random selection provides neither personalization benefits nor a guarantee of comprehensive educational coverage. Option D is incorrect because a fixed curriculum eliminates personalization entirely, failing to adapt to individual learning needs and pace. Constrained optimization brilliantly balances personalization with comprehensive educational coverage. This approach personalizes learning within boundaries, ensuring all essential topics are covered while adapting to individual styles. Think of it as a customizable journey where you can choose your route, but must visit all important landmarks. The system optimizes for engagement and learning efficiency while constraining the path to include fundamental concepts needed for advanced topics. The agent might make hundreds of decisions before receiving any reward signal, creating a credit assignment problem, unlike continuous action spaces or deterministic outcomes which actually simplify learning. Sparse rewards force agents to explore extensively and maintain long-term memory of action sequences. You have reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.